Okay, so here we got the general velocity given here as 4 sine 2t I plus 15 cos 5t j. And it says in part A, find the magnitude of the force acting on the particle at time t equals 3 pi over 2. Now remember, when they talk about force, we're always going to think about Newton's second law, right? Force is mass times acceleration. So I need the acceleration, all right? So to get the acceleration, remember, the acceleration is the rate of change of velocity. So we're going to differentiate this, okay? And when you differentiate sine, it becomes cos, doesn't it? So this will become 4 times cos of 2t times 2, don't forget. And then cos becomes minus sine, so this will be minus 15 sine of 5t times the derivative times the 5, yeah? So I get, so then on the next line then, 2 at the front times it by the 4, you get 8. Bring the 5 to the front, so you get 75 sine 5t j, okay? So then, what I'm going to do, because that is my acceleration now, I'm literally going to work out the acceleration, okay, when t is that, okay? So when t is equal to 3 pi over 2, okay, the acceleration will equal to 8 cos. Now you've got 2t here, so it'll be 2 times 3 pi over 2, aye? And then minus 75 sine, that'll be 5 pi, 5 times 3 pi, isn't it? This is 5t, 5 times 3 pi, so that's 15 pi over 2, yeah? J. Okay, so on my calculator then I'll work this out. Now, those 2's would actually cancel, wouldn't they? Okay, so I get 8 cos 3 pi, okay, which turns out to be minus 8 I, and then 75 sine 15 pi over 2, which turns out to be minus 75, but there's already a minus there, isn't it? Okay, so it actually then should be, so if I check the minus in front, you'll see what I mean then. So that's what is there. So if I type that in, it comes up as positive 75, right? J. Now, careful here, right? Because they're not asking for the force in vector form. They want the magnitude of the force, okay? They want the size of it, okay? So if they were asking for the force, they would put it in bold if they wanted it in vector form, okay? If they wanted it in vector form, they put it in bold, but they don't want it, they just want the size of it. So what we need to do here is get the size of this, the magnitude of it. And to get the magnitude of it, remember, just do the modulus. It's like using Pythagoras, okay? So we literally square those two, okay? Add them, square them both, add them, and square root, okay? So that's what we need to do to get the actual size of the acceleration. Okay, so that comes out to be, oh, it's not very nice, 75.425 to 3 decimal places, okay? So I don't need to underline it anymore because I've literally got the acceleration there. Okay, worked out. So then to get the force, it is literally mass times acceleration. So in this case, the mass is 3 kilograms, and then you've got the acceleration, which we just worked out. So if I do that on my calculator, just times the answer by 3, it comes out to be 226.28 newtons. Okay, right, so part B then, it says, determine the position vector of the particle at time t. So again, we've got v equals to 4 sine 2t I plus 15 cos 5t j. Alright, now to get the position vector, remember, r is what we need, okay? But you just need to appreciate that v is equal to dr by dt, isn't it? Okay, that's what v is, the rate of change of displacement. So if I separate the variables, I got dr equals then to 4 sine 2t I plus 15 cos 5t j dt. Okay, so dr then becomes r, because this is 1 dr. Integrate this. Now, when you integrate sine, it becomes minus cos, yeah? When you integrate sine minus cos, you get minus 4 cos 2t over then 2, because there's 2 there, I. And when you integrate cos, you get positive sine. So then it'll be plus then 15 sine 5t over 5j plus c, okay? So r then will be minus 2 cos 2ti plus 3 sine 5tj plus our c. So we can work out our c because they probably give us conditions here. So let's read it. It says at time t equals 0, the particle has position vector minus 2i plus 3j. So I can literally put that in here, okay, when t is 0. Now when t is 0, cos of 0 is 1, right? So I get minus 2i there. Sine of 0 though is 0. So then you get your c to be, well, c just turns out to be just 3j then, okay? Because the minus 2i's cancel. Alright, so we've got then our general answer then for part B, minus 2 cos 2ti, and then you've got, well, we can put the 3j and that together, so we've got 3 plus 3 sine 5tj, okay? Now, part C then, it says, calculate the time and the distance of the particle from the origin when it crosses the y-axis for the first time. If you think about it, when it crosses the y-axis, okay, so here's the y-axis, yeah, the vertical axis. Well, when it crosses the y-axis, it could cross anywhere here, but the I component will be 0, if you think about it, yeah? Okay, because remember now, I goes across, okay, in the x direction, and j's go up in the y direction. So when it crosses the y-axis, the i's will be 0. In other words, this is 0. So the I component is 0 on the y-axis. So 2 cos 2t will equal to 0, which means cos 2t is equal to 0. Now, all you've got to do then is cos to the minus 1 of 0, okay, on your calculator. Okay, so because you take the cos over, do cos inverse, and if you do cos minus 1 of 0, of course that comes out to be pi over 2. So you've got 2t is pi over 2, so then to get t, you take the 2 over and divide, so you end up having 4 there. Pi over 2 divided by 2 is pi over 4. And then, yeah, we've done it, we calculated the time and the distance. To get the distance then, you just need to sub it into there to get your distance. So distance will be 3 plus 3 sine 5 pi over 4. Which comes out to be, I've got 6 minus 3 root 2 over 2, okay? Or 0.878, well, perhaps I'll keep it like that.